So we need to find the solution to this differential equation by reducing it to a variable separable form first. So let us begin. Rewrite the given differential equation as 2 times dy over dx, that will be equals to 1 minus cosine squared x minus 2y. Now we're going to suppose that x minus 2y, so let that be equals to some other variable v. Then we differentiate both sides with respect to x, and that will going to give us 1 minus 2 times dy over dx, that's equals to dv over dx. Now we can isolate 2 times dy over dx, and that is going to give us 1 minus dv over dx. Now what we will do, we'll substitute this value into our original differential equation. So this one, so this should give us now 1 minus dv over dx, so that's equals to 1 minus cos squared, x minus 2y will get replaced with v. So from both sides we have 1, so we can cancel out the 1 from both sides and multiply both sides with -1. So this will leave us with dv over dx equals to cosine squared v, and when we separate the differentials we have dx as equals to dv over cos squared v. And we know that the reciprocal of cosine function is the secant function, so we have secant squared v dv. So now we have, and the different dx is equal, let me write it down, equals to secant squared v dv. So this is now in the separable form, so that means we can integrate both sides. So integration of dx is pretty straightforward, that's x, and similarly integration of secant squared v, so that will be tangent of v plus the constant of integration. So we suppose that our value v was equals to x minus 2y, so let's replace that value. So we have x equals to tangent of x minus 2y plus the constant of integration c, and this is the required solution to our given differential equation.